In this video, we're going to take a look at how to find sides and angle measures of triangles that are not right triangles. So to this point, our study of triangle solutions have been to right triangles. However, many triangles that require solution do not contain a right angle. Such triangles are called oblique triangles. We now discuss solutions of oblique triangles. So we know that we need to know three parts of a triangle, at least one of them a side, to be able to solve it. So there are four possible combinations of parts, and these are as follows. So case 1, you could have two angles and one side. Case 2, two sides and the angle opposite one of them. These are the two cases that we're going to use something called the law of sines. Then case 3, two sides and the included angle, and three sides we're going to do in a different section, and we're going to use something called the law of cosines. So what is the law of sines? So if you take a look at an oblique triangle, then what you can do is you can cut it basically into two right triangles. And the height is at right angles from the B up top from the vertex. So we cut this into two triangles. Then I can write the sine of angle A is equal to the opposite side H over the hypotenuse C. The sine of angle C in the other triangle is equal to the opposite H over A. And I want to solve both of these equations for H, for the height. Height equals C times the sine of A. Height equals A times the sine of C. Since height equals both of these expressions, then we can set them equal to each other. And what happens if I divide both sides, I have C times the sine of A equals A times the sine of C. If I divide both sides by the sine of C and the sine of A, I get this relationship that C divided by the sine of C is equal to A divided by the sine of A, and that's expressed in just the side lengths and angles of the original triangle. So what the law of sines says is that in any oblique triangle, this relationship is true. That if you take side A over the sine of the opposite angle, it's in proportion to side B over the sine of angle B, which is in proportion to C over the sine of C. So this says that the side lengths are proportional to the angles, the sine of the angles across. So what we do is we use these as needed, okay? So here, let's see what that means. So example 1, where we have two angles in one side, I have to draw the triangle first. And I'm going to label, and I'm not too worried on this one about keeping my drawing to scale. I have A, little side A is opposite, C, little side C is opposite, B, little side B is opposite. So we're given that side length C is 6, and A is 60 degrees. Angle B is 40 degrees. And we want to find A, B, and C. So take a look at what we have. We have angle A and angle B. We can find angle C by subtraction. So any triangle, the sum of the three angles is 180 degrees. So if you're given two angles, you can always get the third one. So angle C is going to equal 180 minus angle A, 60, minus angle B, 40, minus 100, which leaves us with 80 degrees. So angle C is equal to 80 degrees. Now I've got the three angles exactly, and now I can work on the side lengths. So I use what I have and what I'm trying to find. So I have 80 degrees and I have the side opposite. So I'm going to use C over the sine of C, because I have those two values, is equal to A over the sine of A. Substitute your numbers in. I get 6 over the sine of 80 degrees is equal to little side A over the sine of 60 degrees. Multiply both sides by the sine 60 degrees. I get 6 times the sine of 60 divided by the sine of 80 is equal to little side a. So make sure your calculator is in degrees, and we're going to go ahead and do that. So I have 6 times the sine of 60 in the parentheses divided by the sine of 80. And I end up with little a has a side length of about 5.28. Now I want to find little side b. I'm going to use the ratio of c to sine c because that's exact. I didn't round anything to get there. So I'm going to take 6 over the sine of 80 degrees is equal to little side b over the sine 40 degrees. Multiply both sides by the sine 40. I get 6 times the sine 40 divided by the sine 80 is equal to b. Type it in the calculator. So I get 6 times sine 40 degrees divided by the sine 80. And we end up with about 3.92. So it's a pretty straightforward problem if you're given two angles in one side. So the second, let me take a little. So the second case where we can use the law of sines is if we have two sides and the angle opposite one of them. This is not as straightforward. So what can happen if you're given two sides and an angle opposite, it might be possible that there's no solution. It might be possible if a right triangle solution, you might get one solution, and it might be possible that you get two solutions. So how can that happen? So when you're trying to find an angle, you have to take the sine, inverse sine, and it gets a little tricky because remember back when we were looking at sines of angles, in the first quadrant, a 30-degree angle has a sine of 0.5, but it's also a reference angle in the second quadrant. So that angle, 180 minus 30 degrees, 150 degrees, also has a sine of 0.5. So when you're given two side lengths and you're trying to find the angle, there is more than one angle that might correspond to that particular value. So what I mean is the inverse sine of a half has two answers, 30 degrees and 150 degrees, and they both might be possibilities in a triangle. So let's take a look and see what happens if we do end up with two solutions. So now we're going to solve the triangle with the following given parts. We have two sides, A is 40, B is 60, and an angle of 30 degrees. So let's draw that triangle. And it would probably be better if I could draw it to scale. Okay, so I'm just going to pick A, B, and C. So little side A is 40. Little side B is 60. And angle A is 30 degrees. Okay, we can't use Pythagorean theorem because remember that this is not a right triangle. So I don't have angle B or C. So what I want to be able to find, I have little side A and little side B, and angle A. So the first thing I can find on here is angle B. So I'm going to write my A over the sine A is equal to little side B over the sine of angle B. So little side A is 40 over the sine 30 is equal to B, which is 60, over the sine of angle B. And I'm trying to find the sine of angle B. So let's cross multiply. 40 times the sine B is equal to 60 times sine 30. Divide both sides by 40. So I get the sine of angle B is equal to 60 times the sine 30 over 40. Okay, so I'm going to put that in the calculator. Actually, I think I want to do the inverse sine. I don't want to round to the final answer. So inverse sine of this expression, 60 times the sine of 30 degrees over 40, is going to equal the angle that I'm looking for. So in the calculator, let's go with inverse sine. 60 times the sine of 30 divided by 40. And I end up with an angle of about 48.6 degrees. I'm going to round it to the nearest tenth. So to keep in mind, that's not the only angle that has that sign. So there's an angle B of 48.6 degrees. There's also a reference angle of 180 minus 48.6 degrees that has that same sign. Oops. So when I take 180 minus 48.6, I end up with 131.4 degrees. Oops, that's not exactly true. Hang on here. Okay, that was right. Let me keep going. So I had to look something up real quick. So that's 131.4 degrees. So that means there's two possible triangles. Two triangles. One of them, angle B, is equal to 48.6 degrees. The second triangle, angle B, is equal to 131.4 degrees. Okay, so we have two triangles to solve. In the first case, if angle B is 48.6, then now we can find angle C, because angle C is going to equal plus angle B, 48.6, plus angle A, which is 30 degrees, equals 180 degrees. So angle C is going to equal 101.4 degrees. And now I can find small length side C. So there's angle C, there's angle B, and little side length C is going to be side length C over the sine of 101.4 degrees is going to equal, let's pick the first value that we had, 40 over the sine of 30 degrees. This time we can cross multiply. We just need to multiply both sides. We get 40 times the sine of 101.4 degrees divided by the sine of 30 degrees. Type that in the calculator. Then side C is about 78.4. So in case number one, angle B is 48.6 degrees, angle C is 101.4 degrees, and then little side length C is 78.4. So in the second triangle, if angle B is 131.4 degrees, then we get angle A, angle C plus 131.4 degrees plus 30 degrees is equal to 180 degrees. So in this triangle, angle C is equal to, we do our subtraction. Let me get the calculator up here. 18.6 degrees. So that makes it another triangle. Okay, now we find little side length C by using, let's see, we have A, which is 40 over the sine of 30 degrees is equal to little side c over the sine of 18.6 degrees. Multiply both sides by the sine of 18.6 degrees times 40 over the sine 30, and that will give us side length c. So side length c is equal to 25, approximately 25.5 in the second triangle. So that's the case where you have two possibilities. So it could happen that you have, so let's look back at our chart. You have two solutions if b times the sine of a is less than a is less than b. Then if you check here, let me write it down. Two solutions if b times the sine of a is less than b. So b times the sine of a, so 60 times the sine of 30. Is that less than a, which is 40, which is less than b, which is 60? So if we get 60 times the sine of 30, we end up with 30, which is less than 40, less than 60. So that's how you tell if you're going to have two solutions or not. So use this chart when you're given two sides in the angle opposite to see what's going to happen, and then it will let you know whether you are going to have two solutions, one solution, or no solutions. All right, we'll take a look at one word problem. This one's from homework. It says, use the law of sines to solve the given problem. A small island is approximately a triangle in shape. So I'm going to draw a triangle in shape. If the longest side of the island is 530 meters, so we'll call this the longest side, and two of the angles are 35 degrees and 60 degrees, 35 degrees and 60 degrees, then how come I know those are these two angles? Well, the longest side has to be opposite the largest angle. So to find that angle, I take 180 degrees minus 35 minus 60. 180 minus 35 minus 60. And I end up with 85 degrees. So I know that this 85-degree angle is across from the longest side, and that's how I know that the two angles given are these two. All right, then the question says, what is the length of the shortest side? The shortest side is opposite the shortest angle, so 35 degrees. So this is what we're looking for, is this side over here. So we can set it up as a over the sine of 35 degrees is equal to 530 over the sine of 85 degrees. Multiply both sides by sine of 35. I get 530 times the sine of 35 degrees divided by the sine 85 degrees. And I'll have to do that on my calculator. 530 times the sine of 35, and divide that answer by the sine of 85. And I end up with 305.16. And we want to round to the nearest integer as needed. So that would be 305 meters.